Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, so homework for lesson 7.1.6. Our M&Ms have to do with fraction busters. So this is the process that you can use to eliminate the denominators from your fractions and make your equation an easier, more appealing equation to try and solve. So if you take x over 3 plus x over 5 is equal to 2, and you don't want to have to deal with those fractions, you don't technically have to. You can identify the least common denominator of 3 and 5, which is 15. And if you multiply every single term times 15, what happens is you end up with 15 divided by 3. So it's kind of like, here, let me show it this way, where you would like take this and cancel that out, and you take this and you divide the 3, leaving you with a 5, so it becomes 5 times x, which is 5x. Here you'd cancel out the 5, and this is 3 times 5, so the 5 cancels out, leaving you with 3 times x, so that's how you get your 3x. And here nothing cancels out, so it's just going to stay as 15 times 2, which is 30. So 5x plus 3x is equal to 30 is equivalent to the original equation, but it's a lot easier to solve. You add 5x and 3x together, then you divide by 8, and you get x is equal to 3.75. And if you plug that in here and work through the process, you would check it, and it would absolutely work, as is shown here. Okay, so let's see if we get some of this in our homework that we can practice. We do. So use fraction busters to solve the following problems. In this case, if I were to multiply everything times 10, that would cancel out the 2, the 5, and the 10. So I'm going to choose to multiply. Let me actually make this a little bit thinner. If I multiply this times 10, I'm going to write it as 2 times 5 here, 2 times 5 here, but I'm just going to go ahead and write it as a 10 here because the entire 10 cancels out, and that's going to leave you with a 7. Here, the 5 will cancel out, leaving you with 2 times 2x, which is 4x. And here, the 2 cancels out, leaving you with 5 times 3, which is 15. So I don't really like how thin I've got that. Let's broaden that up a little bit. There we go. So now let's go ahead and solve by subtracting 15 from each side. That gives us 4x is equal to negative 8. And then when you divide each side by 2, you're going to get x is equal to negative 2. Now, we should check. Let's make sure that this absolutely was correct and it works. If I plug in negative 2 here, that becomes negative 4. So for the check, it's 3 over 2 plus negative 4 over 5 is supposed to give us 7 over 10 for an answer. So I'm going to change these both. So this becomes 15 over 10. This is going to become negative 8 over 10. And when you add those together, you get 7/10. Yes, you do. That means our answer is correct. Stop it. Yes. Let's move this guy over there so they don't blend together. Let's do the same thing over here, where you got 5, 6, and 3. So I'm thinking it might have to be 30, right? Because 6 times 5 is 30. I can't think of any other multiple that all 3 of them go into. So let's multiply. Let me thin this out a little bit. Multiply this 3 times 10. This one will be 5 times 6. And this one will be 5 times 6. So the 5s cancel out, leaving you with negative 48x. Here, the 6s cancel out, leaving you with 5 times 1. And here, the 3 cancels out, leaving you with negative 50 times x. I will choose to add 50 to each side so that everything cancels out here, and then I will take away 5 from each side. So they cancel, leaving you with negative 5. This ends up giving you 2x. Now when you divide by 2, you get x equals negative 5 over 2, or negative 2.5. So that ends up being our answer. I'm going to move on. I don't want this to take too long, but you could absolutely check this as well, and it will absolutely work. All right, find the value of x that makes each equation true. So this is not quite as bad as the previous. In this case, you're going to divide each side by negative 4.9, and 9.8 divided by negative 4.9 gives you negative 2 because it's a positive divided by negative, and we can check that. A negative times a negative gives you a positive, and 2 times 4.9 is 9.8. I'm sure of it. 2 times 4.9, yes, no. 2 times 4.9, yes, 9.8. Here, I think in this problem, we need to multiply each side times 7 over negative 2, right? Because that's the reciprocal of this, right? 7 over negative 2, when you multiply here, ends up giving you an answer. This cancels that cancels that. So x is going to be equal to 56 over negative 42, which can be simplified. And it looks like 56 and 42 have 7 in common. So if you divide the top and the bottom by 7, you end up with 8 over negative 6. Oh, that can still be subtracted or done a little bit more to 4 over negative 3. And rather than say 4 over negative 3, let's call it negative 4 over positive 3, because I don't like having the negative sign in the denominator. And then here, do you want to use fraction busters, or do you just want to subtract 3/5 from 2/3? Because you could just do this. I mean, right? Subtracting 3/5 from each side, and then you need a common denominator. So you're going to get your common denominator anyway. So you just end up with 1/15. So you might as well just say x is equal to 1/15. That works too. Or we multiply everything times 15. And this becomes 15 plus 15x is equal to, what is that, 30 over 3 equals 10. When I subtract 15 from each side, I made a mistake somewhere. Where's my mistake? That's my mistake. That's not supposed to be 15 there. See, that's why I don't like doing it that way. Got to do it a different way. Sorry, this is bugging you. I have that special quality. Let me just copy down the whole thing. 3/5 plus x equals 2/3. So I'm going to multiply this times 3 times 5. I'm going to multiply this times 15. I'm going to multiply this times 3 times 5. And what do we get here? The 5s cancel out. Oh, that was supposed to be a 9, not a 15. This is going to be 15x, and this cancels out the 3, and that gives you a 10. So when you subtract 9 from each side, you get 15x is equal to 1, and then x isn't equal to 15, x is equal to 1/15. All right, 5D process. Trina planted 43 plants in her garden last week. She planted twice as many cucumbers as zucchinis. All right, so twice as many cucumbers as zucchinis, and 8 more tomatoes than cucumbers. All right, so part of me is thinking that we should make the cucumbers the x, and that would have to make the zucchinis half of an x. I would rather not do that. So I'm going to go ahead and stick with zucchinis being my x, and twice as many cucumbers means there's 2x, and then 8 more tomatoes than cucumbers means 8 more than 2x. That seems a lot easier, so we don't have to worry about having any fractions for our coefficients. So 2x plus x plus 2x plus 8 is 5x plus 8 is 43. Take away 8 from each side, divide by 5, you get x has to be equal to 7. So the number of cucumbers is 7. It says write and solve an equation. If you need to be sure to define your variable. What are we trying to do? Find the number of each plant. So if that's 7, this is 14, and this must be 8 more than 14, which is 22. So when we add them all together, they're supposed to equal the 48. No, 43. So 11, 12, 13, carry the 1. That is it. So we can declare Trina planted 14 cucumber plants, 7 zucchini, and 22 tomato plants. All right, goal scaling, making sure we remember how this works. Remember, these have to all be evenly spaced with the same counting sequence. So if it takes you 3 steps, 1, 2, 3 to get to 60, then you must be counting by 20. So 20, 40, 60, 80, 100. Here it takes you 1, 2, 3, 4 steps to get to 60. So we must be counting by 15s. 15, 30, 45, 60, 75. This one takes you 1, 2, 3, 4 steps to get to 100. So 100 divided by 4 equals 25. So we're counting by 25. So it's 25, 50, 75, 100, 125. And the last one, you're counting by 50s because 2 steps to get to 100, you must be counting by 50s, and so on and so forth. Oh, a box plot. Is this the last problem? No, no. Oh, goodness. I'm so sorry, all this work. But you know what? It's math class. You got to do this work if you're going to master it. So let's do it. How much time have we taken so far? All right. This is going to be over 15 minutes. This problem alone will take 5. Mount Rose Middle School collected canned food to donate to a local charity. Each classroom kept track of how many cans they collected. The number of cans in each room are as follows. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classrooms. Okay, the principal displayed this data here. So, what is the interquartile range? Well, that's pretty straightforward. The difference to get from the first quartile to the third quartile goes from 62 to 80, so that is 18. Notice how the median is 73.5. If we put these in order from least to greatest, the number in the middle, there must be 2 numbers in the middle. What would it be? 70 and 77 must be in the middle because their average is 73.5. The minimum is 39, the maximum is 107, and then you got your quartiles. All right, the main office collected 55 cans, the counseling staff 89, and the custodial staff 67. So now we've got to create a new box plot by plugging in these numbers. And now we've got a total of 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got to work through the process. We've got to find the minimum, the maximum, the median, and the 2 quartiles. So start with the minimum. That's easy. 39. Go to the maximum. That's easy. That is 107. Now find the number that's in the middle. If we had 13, then half of 13 is what, 6.5. So 1, 2, 3, 4, 5, 6. This number must be in the middle. 1, 2, 3, 4, 5, 6. That's the median. Now to find the quartiles, we are going to find the median of the lower half, which is the halfway point between these 2 numbers, and the halfway point between the, what is it, 1, 2, 3, 4, oh, wait. Yeah, we got 6 numbers up here, don't we? Just like we got 6 numbers there. Halfway point between those 2. Halfway point between 55 and 62. Let's do this on the calculator. 55 plus 62 is 117. Divide that by 2. It must be 58.5. That's what we've got right there. And the halfway point between those 2 is pretty easy. Halfway point, it must be 83. So now we're going to plug this data into a new number line. So our new number line has to be properly scaled. We need to be able to fit the minimum and the maximum. So I went from 30 to 110. I decided to count by tens. So where does 39 fit on here? Right around here. Where does 107 fit? That's 105, so 107 is going to be right around here. Where does 70? Well, that's easy. That's right there. And then 58.5, that's probably somewhere in this vicinity. And 83, there's 85, so 83 is going to be somewhere around there. So you find the respective points and then create your whiskers and your box with your interquartile range, and you've got everything labeled and you've got it complete. All right, now we're going to create a stem and leaf plot. Ages of golfers participating in a golf tournament were blah, 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 blah. Okay, lots of data there. Creating a stem and leaf plot is going to help you put them in order from least to greatest. So the first thing I would do is start with an unordered box plot, okay? Not box plot, ordered stem and leaf plant. So just go and put them in. So you know you got numbers in the 20s, you got numbers in the 30s, numbers in the 40s, numbers in the 50s, numbers in the 60s, and it looks like the oldest person was 74. So we've got to account for 1, 2, 3, 4, 5, 6 decades. So we're going to start with the 20s, then the 30s, then the 40s, then the 50s, then the 60s, and then the 70s. We just put them in as we see them, and then we need to put them into order. Putting them into order is very, very important. We want to just, if we're going to find the median of all of this, it's really impossible to do if it's not in order. So this is another way of ordering the data. Now, would you want to put all of these in order from least to greatest and write every single number down? No, you would not. Putting it into the stem and leaf plot makes it a little bit more efficient. So here you got 25, 28, 29. These are already in order. But here we got to start with the 0, 2, 3. You got a couple of 4s, and you got a couple of 5s, and you got a 7, and you got an 8. Okay, so you got golfers that are 30, 32, 33, 34, 35, 37, and 38. And so on and so forth. Don't forget, we want the key here. So these ages are 2-digit numbers where the first digit is in the tens place and the second digit, the leaves, are in the ones place. So that's what this key tells us, that 7 line 4 means a person who is 74 years old. So it says, describe the shape of the spread of the data. Did it tell us to create a histogram? I don't know if it, where did it tell us to do a histogram? Oh, yes, right there, create the histogram. All right. So it looks kind of like, looks like the greatest range of ages are in the 30s and 40s. This is sort of symmetrical, kind of, following that kind of a bell curve kind of thing, although this one didn't match that, and these two don't match that. But it's kind of trying to be a bell curve kind of symmetry. Not perfect, so technically it is non-symmetric, but it's trying to. There is one large peak, and we might suggest that the 74-year-old is an outlier. I don't know that it truly is. It's not like you had a 100-year-old with a bunch of teenagers playing. And then the median would be the better average to use, because if we assume that there's an outlier, it's going to be more accurate. So how do you find the median from all of this? Well, how many total ages do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So find the 15th number in this sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Go backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our median, wait, did I get that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got that wrong. It's supposed to be 43, not 42 and a half. Didn't get it perfect. Oh well, life moves on. That was pretty close though. Maybe I accidentally found the mean instead of the median. I don't know. At any rate, this was a lot of work and a lot of fun. I'm certain of it. All right, I think that's it. They would not make us do another problem after this one, I'm sure. They did not. All right, let's move on. We probably have ourselves an assessment to take. Take care. Bye.
Hey, feeling good, like I should. When